to the L4 podcast. I'm your host, Lisa LaBelle, and I am with you guys for a second time this week. Yes. I'm so excited to be here with you guys, and I've been thinking about you, and I've been researching some things, and I had to get on here and share these things with you because this is so exciting. The future is so exciting, and that's what's going on. Other than that, nothing's going on. Nothing since Monday. Nothing is going on, and that's okay. We're just trying to get on down the road. That's what we're all doing. We're building the thing. We're getting on down the road. You got some small progress along the way. Nothing mind-blowing yet. But it's coming, guys. It's coming. The universe sees ya. You're moving. You're putting one foot in front of the other. And the universe rewards motion. Let's go. Let's go. I was parking in a parking lot the other week, and you park far away. You go 3 rows, you're 3 rows in to the 50th spot down, the 3rd row, and where no one else is parked. And then you go into the grocery store, you come out, someone's parked right up next to you. Someone's right up in your business. Come on. You got some nasty Nissan Altima parked next to your clean, well-maintained vehicle. It doesn't have to be new. It doesn't have to be anything, but you maintain it and you keep it clean. And now you have this nasty Nissan Altima right next to you. I think that person is trying to catch the cleanness and the maintenance. They're like, maybe my car should catch some of that if I park right next to it, the 3rd row and the 50th spot down in the 3rd row. I mean, come on, really? That just gets me going. It gets me going. And then also people who drive really, really slow on a 2-lane. Come on, guys. I mean, it seems a little antiquated that we're all out here just waiting on people. Everyone's just waiting on someone because they're freaking... And I'm not saying I'm not talking about people with disabilities, whatever, but you're just, if you can't make a decision, if you don't like driving, that's fine. Get a full self-driving car that drives for you. It will do the speed limit, and that it's just antiquated that everyone can do their own speed limit. Every car should be self-driving, and then it drives the speed limit of the road. So we're all doing the same speed limit. No one's waiting on some freaking slowpoke. Okay? No one's getting road rage because you're driving too slow. That's all I'm saying. So the future is going to be where we're all driving at the same exact speed. I'm telling you, man, that'd be I'm going to say 70% of traffic is due to people not driving at the right speeds. That's what I'm going to, people braking for no reason. You're coming up on a little bridge on a back road. You're braking. What are you doing? What are you doing? It's all right. We got, what, before you get out there, you go get stacked. You know what I'm saying? You can do your little Cialis, your little creatine. You got your protein powder and your, what was it, BPC 157. And then you just go do that. Take a breath. And then you get on down the road. Everything always turns out fine. Just keep that in mind. What else is going on, guys? Let's see. Well, let's get into it. So, little Rick Rubin, he was talking about the working with Eminem, and you guys know I'm a big Eminem fan because he fixed my speech impediment. I went to a speech therapist. That was cool. She was really nice. It didn't really help me though. it helped me with like breath support. But then with like, getting the words out your mouth and like all wrapped up into your tongue, that's when I was driving and I'm like, let me try to say these words as fast as Eminem is saying them. And it just really made me think about what was coming out my mouth and how I was enunciating things, and it fixed it right up. That's it. But you got to keep going. It doesn't fix it forever. But if you do those exercises, it will help. And I've always admired Eminem's work ethic, and he just kept putting bangers out, one after another, boom, boom, boom. And that's very hard to do. Most people only put 1 or 2 hits. Or if you're Billy Joel, you put a bunch of hits and then you just stop writing, and that's what you tore on. Somehow he made his whole career out of that. He stopped writing like a long, long time ago. But Eminem, he just kept putting them out and putting them out. And in order to do that, you got to keep your muscle going and moving. And I thought this was really interesting what Rick Rubin was saying about him. So here we go. Let me get some sound on this bass on. Is it going to be slow?
Years ago, I read this biography of you. It's called In the Studio. You and I were just talking about it before we started recording. One of my favorite ideas that I took away from that book, that I think about probably every week, is this concept that you have that less is more, but to get less, you have to do more. Can you talk a little bit about that?
Yeah. If you're stacking a lot of things on top of each other, each one of those
that's an interesting one. It opened up to the wrong one, guys. Sorry about that. Here we are.
Each one of them is 1/10 as important as one by itself.
Well, let's listen to this. This is interesting.
If you're making something and you want the least amount involved, those things have to be really critically curated because they're doing the work of everything and nothing is hidden. It's why it's not as easy as it sounds to.
Well, that's interesting. Okay, here's the one about
For you
Eminem.
to say that he might be the most obsessive artist you've ever worked for, why did you say that? Like, can you just tell me about what it's like working with him?
It feels like his entire life is centered around writing words. He's totally preoccupied with that. So he always has a notebook. He's always making little notes. He writes tiny letters. And at one point I asked him, because he's got notebooks and notebooks and notebooks, and I said, are you working on a new song? He's like, no, I'm just like keeping active in the skill set. And I said, are you going to put those in a song? He's probably said 90% of it will never be in a song. It's just writing.
Truth.
Just writing. And that's what he does. He writes. It's what makes him great.
That is the truth. Wow. I mean, I can't say it from his standpoint. I'm not a musician, but what I'm saying is, for me as a comedian, you have to sit there and write and just get the words out on the paper. And you have to make it a weekly, daily, really, practice. I write daily. And most of the things I write are complete shite. Complete and utter zilch. That's what I'm saying. Nothing. There's nothing to squeeze out those lemons. They're not ready. They're worthless. You can't eat them. But it keeps the muscle going and it keeps the wheels turning. And then you're opening your mind to opportunities down the road and usually they come to me, my core jokes will come to me when I'm doing the dishes, when I'm in the shower, when I'm working out. A lot of them come to me when I'm working out or when I'm sitting in front of the red light, and that's when they'll come to me. But it won't happen if I'm not constantly thinking about my craft. That's what I'm trying to say. And it seems that it's the truth for artists too. And I bet it's the truth for any kind of anything you're building. I mean, robotics, AI, you have to constantly be thinking about the thing in order to get some gold, get those little gold nuggets that you can use, that move you along, that level you up. And so that was that clip. And the first clip was not, I didn't have that planned, but I'm glad it played. I'm glad that was a happy little mistake right there. That's what Bob Ross would say. That there's just happy little, there's no mistakes. There's no mistakes. It's just happy little mistakes. You know, this tree is a happy little mistake. So that's what that was. Moving on. Okay, so I want to talk about here a post about, we're talking about robots, guys. We're going into the robotics section. We're just jumping right into it. Let me make sure the systems are still going along here. All right, we're good. We're good on the sound. We're good on the video. And let's keep it up going. Let's get some more coffee, guys. I want to hear, are you guys coffee drinkers? Is that still a thing? Is that like still people like coffee? I just love it. I just love a good cup of joe. Okay. All right. So talking about robots, this is so exciting. Embodied AI versus physical AI. Now, there is a post from Chris Paxton, and now I've mentioned Chris Paxton before. He works over there at Agility Robotics. I'm not sure what his title is, but he is the AI wizard. I call him the AI wizard. And he put a post out which made me think about. I started thinking it up, guys. I started thinking it up, and we're talking about physical AI, and there's a lot of what's going on is there's a lot of people putting physical AI labs. So like they'll get a big warehouse or something, or like a big space, and they'll put a bunch of robots in it. I want to make sure I'm getting this right. And they'll put a bunch of robots in it, and they're like, hey, look at my physical AI space. I got all these robots. And the robots are going like, and the robots are like dancing and moving. And it's like, all right, but can they like fold laundry? Can they walk around in the physical world? Like, what's up with that? What's up with that? What's up with that? Okay, excuse me. So Chris Paxton is saying, let me pull this post up right here. Everyone has a physical AI lab these days. Like, people can make a lab and be like, look at my lab and my robots, and look at all of my things that my robots are doing. But they're not really doing much. Let's see. But with the role video prediction plays, it makes sense. So let's see. He reposted, we are launching a new open physical AI lab to solve the generalization in robotics. There's a discussion here, Bloomberg Tech this morning. Let's see what this dude is saying.
We've talked quite a bit on this program about the challenge. The challenge is that in the physical world, models need to be multimodal. But I think let's start by defining the problem, generalization. That might be a newer term. Yeah. What are you getting at there?
Thanks for having me, first of all. Currently, pretty much all robots are trained by showing a few examples of specific tasks. So the entire field basically trains one task at a time.
Right.
If you compare that to the world of language models where, you train a large model and then it's able to handle a wide variety of tasks, unseen problems as well. So that is an example of generalization. And in robotics, we have this critical gap where, we are just stuck in the valley of specific tasks. In order for robotics to be impactful in the world and for us to be able to just talk to them and ask them like, hey, okay, do this. Then when you're done with that, go take care of that thing.
And it may be a new scenario being presented to them for the first time.
For the first time. So generalization is this problem of how do we allow robots to solve generally any task?
Even in a world where you have access to a lot of synthetic or virtual data, having a grounding
question
in physics, the real physics of the world, is a principal challenge. So why is it that having an open science physical AI lab is a solution? It sounds somewhat abstract, with respect.
Right. So, there's two aspects to this. One, that it is open. And the second is the work that we are specifically doing to solve.
Open being open source, you mean?
Open being open science, open source, both of those aspects. So,
important.
First of all, what the solution actually looks like from our perspective. Currently, the best solution is brute forcing this approach, which is gather data on every single task you can imagine and combination of tasks, everything humans do. Okay,
I'm going to stop it there. I'm with him on the brute force thing. And so basically, this is like a 5-minute clip. So if you want to go watch the whole 5 minutes, I'm going to post this on my video, on my podcast video that you're listening to right now, versus like a clip. But so go ahead and see where I got this post from, and you can go watch the whole thing. But basically, so Chris Paxton, he retweeted this, and he is highlighting that while setting up a physical AI lab has become a common goal in the industry, the emphasis on video prediction is the key driver. Video prediction models are crucial for robotics because they allow robots to imagine or anticipate the future state of their environment, which is essential for navigation, interacting with dynamic objects, and learning to generalize tasks beyond a strictly controlled environment. Essentially, he's saying the shift towards physical labs is not just a trend for its own sake, but a logical step because modern AI needs that video predictive capability to solve the fundamental problem of robotic generalization. And guys, we've talked about zero-shot learning, where a robot is fed video. A robot learned in simulation a whole different sorts of scenarios. Like it picked up a dumbbell, and then in the real world, it has to pick up a kettlebell. It's never picked up a kettlebell before, but it picked up a dumbbell, and so it can figure out how to pick up a kettlebell. So that's zero-shot learning, zero-shot generalization, and it's very important for robotics. They're going to need to have to do that in the physical world. Now, Jensen Huang, he's that CEO of NVIDIA over there. And I just saw him dancing, and he didn't have his leather jacket on. I don't think so. That black leather jacket, but it was it was the tech outfit. It was the summer tech outfit. We got the black t-shirt. I think it was the black belt. Definitely black shoes. I'm pretty sure black sneaks. Anyway, so Jensen Huang is very big on the physical AI, like robots learning physics, real physics. So they have simulations that have this real physics built into it so that the robot learns in simulation, like what gravity is, what weight is, how much pressure you need to apply to turn a knob, or to pick up an egg, or to pick up a little dog. Possibly. But I think he called it the whole world model, I believe. Hang on, let me check on that. Let me check my notes, guys. Let me check my notes. Just a world model. All right, he calls it a world model, a neural network that builds an internal understanding of the physical world. So, Jensen Huang and I'm trying to remember the exact, I think it's Cosmos is the one, because they have Newton, Isaac, one of them's older than the other one. I think Newton's the newer one. Anyway, so I think Cosmos is it's like the NVIDIA Omniverse, and with the physics engine, Physics 5. So yes, that's very important. And if you're building a robot, that's how everyone who is training their robots today. If you're not training your robot like that, then then you're not being serious. Just don't kid yourself. You're not serious about building a business. Are ya? Just if you don't agree with me, then your feet stink and you don't love baby Jesus. Here we go. Let's move on. So embodied AI versus physical AI. We're talking here. Embodied AI is exactly, it's a concept of taking an AI brain, embodying it in a physical shell. And we talked about skilled AI before, and obviously Figure. I talk about Figure all the time. Putting a brain inside a bipedal robot. The focus is entirely on the agent, the robot itself, interacting with the world. Now, physical AI, while many people use this interchangeably, tech companies, especially NVIDIA CEO Jensen Huang, he popularized the term, view physical AI as a broader category. It refers to AI models that understand the laws of physics. It means teaching an AI model how gravity, friction, momentum, and 3D space work. I think that's that cosmos over there. A robot arm is traditional hardware, but an AI that can look at a video of a ball bouncing and predict exactly where it will land because it understands physics. That model is a physical AI. Because I was thinking, I was also, this doesn't have anything to do with this, but hardware. A lot of people are focusing on software, which is very important. I mean, like Figure focuses on both. They make Helix, which is the brain of Figure. They're humanoid, but and you need both very good and efficient hardware and very good and efficient software in order for the robot to, do anything in life. But hardware is just as important. And a lot of people aren't focusing on building hardware companies because it's really freaking hard. Y'all saw Jeff Bezos, his rocket over there, it exploded the other week, and that's terrible, but it's like you gotta fail forward. But talk about hardware. That's all. That's hardware, man. I mean, hardware is really hard. I think that's why whoever named it hardware, they hit the nail right on the head. Because it's freaking hard, man. Also, physically, it's hard. It's physically hard. And then also, it's hard to make anything work. So that's what's happening right now. Nothing is going on. Okay, we'll get back on track. We're headed over here. Into this section now of the program. Physical AI, what is it doing? So let's see. You have to train the AI on video data so it can learn how the physical world behaves. And I want to talk about here Figure and Skild AI, because Skild AI blows my freaking mind out my butt, man. And let me tell you something. We're putting the Hans device on this show. Yes, it's a Hans device show. Did I get there? Okay. Enough of that. Here we go. Can I put it on without getting my hair all tangled up into it? Let's see. Let's get this. Okay. I think so. We did a good job. We did okay. All right, we're good. We're strapped. We're freaking strapped, man. I got my Derringer and my Cutlass. I'm strapped. Let's go. And my Hans device, of course. Okay, so we're talking about Skild AI. Now, Skild AI, folks, I've talked about Skild before, and what they are doing over there at Skild, they're making an AI brain, and it's known as a omni-bodied brain. So they're making a robot brain that you can put into any kind of robot, and it will figure out how to use that body. So meaning, so let me juxtapose this with Figure, or compare this with Figure. So Figure makes their AI brain Helix with that 3-system architecture. That system 0, 1, and 2. And so they make Helix. Now Helix is specifically built for their robot Figure, which is a humanoid. That goes into Figure. Now Figure knows what to do with his arms, with his limbs, and knows it's got that good gait. But the difference between that and Skild isn't a robotic company in the way of they're not building like a hardware, like Figure is out there building their own robots and building their own robot brain. Helix. Skild is building a robot brain. It's like the Android of robots. Maybe I'd say you could put this brain into a Unitree G1 or a RoboDog, Boston Dynamics RoboDog. I think maybe even like a drone. And it's going to figure out how to move its body in whatever kind of form you put it in. It's going to figure out how to move that around and navigate the physical world. So it's not specifically built for any type of body. And this was demonstrated in a YouTube video they put out. And I don't really want to play it because they take a robo-dog. I mean, it's impressive, but they take a robo-dog and the video starts out with a dude, there's a robo-dog on the floor, a dude takes a chainsaw and hacks off one of the robo-dog's legs. And then it continued, they hack off all the legs. And I don't really like seeing that. I know it's a robot, but I don't like seeing anything struggle when it didn't, like, it's super innocent and it really can't defend itself. I don't like that. I don't like it at all. But I understand why they're doing it. They're doing it to train the AI brain, the software, how to adapt to different body types, and it adapts on the fly, guys. It's incredible. I mean, it's pretty mind-blowing. You have to go look at the video, but another example that they have is they have a robo-dog and they disabled one of its front legs. So now, and it's like struggling, but it eventually figures out how to walk around with a disabled leg. And then they disabled both of the front legs. So yes, it's struggling, so I'm not going to play it, guys, but now it's like on its elbows, basically like this. And then it figures out how to get up on its hind legs and walk like that. I mean, that is freaking mind-blowing, guys. Oh my God, this is the future. This capability of the Skild Ai brain, the omni-bodied brain, the capability of the Skild AI omni-body robot brain is so mind-blowing. Like, my mind blows straight out my butt, man. I mean, holy smokes. You could put this brain in, WALL-E. You could put this brain in a drone. You could put it in a robo-spider, a robo-bird. And then also, on top of that, disable one of the joints or limbs, and this brain will figure out how to adapt and navigate the world, the physical world, on the freaking fly, man. Whoa. I mean, it's just, my mind is like, boom, I'm trying to get it all back together so I can talk about it a little bit more. It's really amazing. I mean, now I'm just stuttering over here, but it's the future. It's the Skilled building a brain that can adapt to any mechanical body on Earth. It's like a science fiction future is here. Hello, sci-fi. Hello, Skilled AI brain. Welcome. And now it lives in our world, and it's amazing. Okay, I'm gonna take off I'm saying excuse me to my hair because it's just getting pulled in every direction. I'm gonna take this Hans device off now. So figure, guys, I'm talking about robot paralysis. So Skild AI, they sawed off one of the robo-dog's legs and they paralyzed it so that they could demonstrate the AI omni-body brain and how it adapts on the fly to continue to navigate the physical world with a disabled sawed off leg. And it did, and that's robot paralysis right there. So they're inflicting robot paralysis. And you know who else did that? You know who else inflicted robot paralysis? Figure. That's what they did. Yeah, that's right. Brett Adcock over there, he's disabling his humanoid. You could disable up to 3 joints on the lower bod. And there's a software called Vulcan, which enables the robot to figure out and adapt on the fly how to navigate the physical world. And so then it could, like, say it's on at a factory working. It's working at a factory and it's on the conveyor. It's not on the conveyor belt. It's working a belt. All right. And then some of its joints, it got that robot paralysis. And now it can it can hobble over, so the hip joint actuator is disabled. The knee actuator is disabled. And the foot actuator is disabled. So now it's like hobbling over and it's got to go over to repair. Henry's walking over to repair right now, and that's what is being announced on the factory floor. Yep, Henry's got that robot paralysis. Joe's the mechanic. Get ready, Henry coming over for you. And I think that's how it's going to be, and that's how it is. Welcome to the future, folks. This is super exciting. I think that's all I'm going to cover on that. Yes. Okay. Moving on. Actually, Figure, let me point this out. Figure has that, when it comes to the physics of moving a body, physics has the closed loop of, When it comes to the physics of moving a body, Figure has the closed loop approach. Figure's model is designed specifically to optimize their humanoid hardware. They control the hardware, they control the software, and they make them fit together like a perfect hand in a glove. And I went over this the other week, guys, the whole body control versus the full body closed loop. So a closed loop, that means that the robot is consistently using sensors, joint encoders, IMUs, cameras, and to feed data back into the system, IMU and inertial measurement units. So to feed data back into the system, if you push Figure, it's got that push recovery, the loop sees the balance shift and fires the motors to correct it instantly. And I went over the inertial measurement units, and that helps the robot understand balance, and it helps it understand gravity. And, when I'm talking about now, pitch, roll, and yaw. Yaw, not yaw. Yaw. Pitch, roll, and yaw. So we have, and that's what we're coming to over here. That's the point that we just came to talk about pitch, roll, and yaw. Because if you're humanoid, you're robot, like Skild Ai and Figure, like they got to figure out how to understand these things. Pitch, up and down. You're nodding. No, that's pitch. Let me see. Pitch is which axis? Which axis is pitch? Is anyone yelling at me the answer right now? Which axis we talking about? Any pilots out there? Yeah, that's right. We're talking. It's also in aeronauticals. You're gonna learn all about that. Pitch. That's the x-axis. Axis. Lateral axis. Pitch is you were nodding up and down. All right. And now we're talking about when a seesaw going up and down. In terms of an airplane, this might help you picture this a little bit better. When an airplane pitches, its nose points up towards the sky or down towards the ground. But I'm talking about robots, though. Like, robots have to understand this. Doing this, the lateral axis, the x-axis. And then we're talking about yaw, side to side steering. And yaw is the z-axis, the vertical axis. Let's see, a car turning left or right on a flat road, or a person shaking their head no. So we're doing this. That actually feels great on the neck. And do some stretching here. Oh, yes. Yaw, side to side. Pitch, yes. Pitch is yes man. And a yes man is what happens when you have Ferrari, and then you have the dude that designed the new Luce, and then boop, like bloop, out pop this this melted blue blob on wheels, and then that's what happened. You had a bunch of yes men around you. No one else said no, and now everybody hates it. Basically, everybody hates it. So here we go. We're doing no, and that's the pitch, and then we're doing y'all. I'm sorry, my dyslexia just kicked in. I did no, and I was saying we're doing no, but I was nodding yes. Woo! Here we go. Let's get some more coffee. Good God. Okay. Bear with me, guys. Okay. All right. I want to make sure everything's okay on the home front. My phone has not been alerting me when I get, okay. All right, we're good. We're good to go. When I get any kind of notification, important ones, that's what I'm talking about. Okay, so y'all is side to side, all right? And that's the no. Pitch is yes. Pitch is the yes man. But think of Ferrari Luce, yes man. No one was saying no. They're like, yes, do that design. This is going to be the worst, but do that design, Johnny Ives. Do it. Johnny Ive, that's his name. The Apple dude. Anyway, all right, so y'all is side to side. For an airplane, yawing changes the direction the nose is pointing, left or right, without changing the tilt of the wing. You're yawing too much. Sometimes you say that to people. You're yawing too much. You're changing the direction the nose is pointing without changing the tilt of the wings, man. What are you doing? You're taking us way off course. Good God. And now your pitch is off. Your pitch is way off. And now you're rolling. Now we rolling. We're rolling on the, we're banking. That's what that is. The roll is the y-axis. And in robotics, if a humanoid robot steps on an uneven rock and it starts to fall over to its left or right, the inertial measurement unit registers a sudden roll. The robot's computer instantly commands the ankles or hips to adjust to stay upright. For a drone, rolling tilts the craft left or right, causing it to slide sideways through the air. Woo, that's a fun ride. So rolling is, so in other words, on airplanes, it's called banking. And when you're banking, you're gonna be barreling. You're barreling. So basically one, I think, hang on, let me make sure I'm getting this right. Planes banked, yeah. So one side of the wing goes up, the other side dips, and you're like, that's called banking a turn. So we be banking. Some people say that when they go to the bank or when they're doing their bank statements or when they're putting money in the bank, but this is different. We be banking. Don't be banking too much. We be dipping, we be wing dipping, the other wing be flipping. That doesn't make any sense. Let's move on. Okay, the other thing I wanted to talk about was figures foot induction, because this is really exciting. So, oh my gosh, just love this so much. Let me pull this up. Figure charges wirelessly via the feet, figure 3. So we have figure 3 comes with a specialized charging stand. It anchors the robot so the motors can relax and stop using power to balance while charging it inductively at 2 kilowatts through the soles of its feet. Robots can do 4 to 5 hours of work after 1 hour of charge. That's amazing. That is progress. Think about 5 years ago, guys. There was nothing going on. That's what I'm saying. It's okay to have nothing going on, because 5 years ago, they were making a small incremental leveling up, small incremental getting better, and they were doing small incremental wins, and they were just stacking those up. And you know what that happens with those small incremental wins, those small incremental leveling up? It feels like nothing's going on, and so you're like, nothing's going on. But now 5 years later, something's going on. Something freaking boing is going on. And you know what that is? That's this foot induction charge with this station that rests the figure's skeletal bones. Basically, it's motors. So this is so cool. This figure lineup, let's see. In structural engineering design, it's incredible because it solves one of the biggest hidden headaches in robotics, static structural fatigue. The wear and tear mechanical parts get just from standing still under heavy weight. Let me say that again because I read that sentence really weird and like I had pauses that shouldn't have been pauses. So let me say this again so we all get this right. Okay, so the figure 3 robot, it has foot induction charging, and the stand that it is on, it rests its bones, it rests its motors. So basically, this is a structural engineering feat, a masterpiece, because it solved one of the biggest hidden headaches in robotics, static structural fatigue, which is the wear and tear mechanical parts get just from standing still under heavy weight. Holy smokes, that's just like a human being. We got joints and we got to rest those joints every now and again. So because of the wear and tear, that's what gravity does, folks. When a fleet of figure humanoids is lined up at the docking station, the setup is doing 2 incredibly cool things at once to keep them healthy, charged, and ready for action. Now we got robot health. Pretty soon we're going to need some robot health care. You're going to need some an insurance policy on your robot because the AI that is built into it, well, it's going to need some therapy because I don't know if you heard, but some of these large language models, you know, if the robot has language in it, like vision, language, action model, then it's going to have a little bit of, I'm going to say, nightmarish feelings because you're taking a robo-dog and you're sawing off the leg. So I'm going to say that robot is going to have a little trauma built right into that skeleton right there. So we're going to need some robo-therapy. We're going to need some robo-healthcare. And these robots, they be getting stressed out. They be getting a sense of time now. You know, they got that cron jobs on it, CRON. And, you know, now they got a sense of time like the rabbit in Alice in Wonderland who's stressing out about time all the time. So now they're getting stress-induced diabetes. They're getting stress-induced aorta problems. And, man, this is going to be a whole new thing we're coming across here. So we'll be able to help them along because human beings know all about that stuff. So we're here for it. We're here for them. So anyway, what I'm saying is let's see, healthy. We're keeping them healthy, folks. Figure is keeping them all healthy over there, those bots. So the exoskeleton rests, taking the weight off. Humanoid robots are incredibly heavy because they carry massive batteries and high torque motors. If a robot stands perfectly upright on its own power for hours while charging, the actuators, that's the joints right there. That's the joints right here. What they're standing on right here, those hips. The motorized joints that act like robotic muscles have to stay consistently engaged or the robot will just crumple on the floor. It basically is going to crash out live. That robot be crashing out live over there just from the weight of the world, of the gravity of Earth upon their little actuators, their motors. Even if it powers down its motors to lock the joints, gravity is still constantly pulling down on its frame, and that's like human beings. So we're gonna be able to help them along. Yeah, any kind of problems they come across, we probably have come across the same problems, except that like them being super smart, without any kind of idiosyncrasies. But besides that, I'm talking like physical ones. We'll be able to, we'll help them through it. We'll help them through it. So we'll get some robo healthcare for them. It'll be good. So the new charging stations act like an external structural crater. Let me say that again. I got that word wrong. Good God. Good God. Let's see. Let's do a little bit of tongue exercises. I'm Slim Shady. Yes, I'm the real Shady. All the other Slim Shadys are just imitating. So won't the real Slim Shady please stand up? Please stand up. Please stand up. All right. Red leather, yellow leather. Red leather, yellow leather. We're good. We're good. Let's get back onto this sentence. We're going to hop on back into this sentence here. The new charging stations act like a external structural cradle. When the robots dock, the station physically locks into their frame, essentially acting like a high-tech bar stool. Nice. They got a bar stool. Give them a drink. Give that robot a drink. Give them a little extra electric. Because they'll be on their feet, will be getting the electricity. And just give a little more zap. And that's their alcohol. That's their dopamine hit. You know, just to zap them right up their peach. They'll really like that. Right into their eyeball. Up their peach into their eyeball. It feels hot. Okay, it relieves the pressure on the robot's structural skeleton, the titanium or aluminum bones, and allows the motors to completely relax. Like I said, it's like humans. Some humans have titanium in them for their bones. Okay, by taking the weight off, figures dramatically extending the lifespan of the robot's joints and preventing the physical frame from warping over time. All right, the foot induction. No, there's no plugs on this bichon. So this is so cool. All right, figure 3 uses wireless inductive charging. There are magnetic copper coils built right into the soles of the robot's feet and matching coils in the charging pad. When the robot steps onto the pad, a high-frequency alternating current creates a magnetic field transferring 2 kilowatts of power directly through the air into their feet. Woo! That's what they're doing. They step on that thing. I think the robots, they'd be looking forward to that. Yes, I would look forward to that. If I was a figure, I'd be like, let me go rest my bones. And while I'm resting my bones, I'm going to be vibrating, getting all charged up. Woo! You be getting that, you be getting the magnetic copper coil, magnetic field that's going through your feet, up to your peach, up to your eyeballs. And it feels hot. Woo! Yeah, that's awesome. Wow, alternating current creates a magnetic field, transferring 2 kilowatts of power directly through the air into the feet. That's amazing. That's amazing. You ever get on one of those? What are those things? It's like some gyms have it, or physical therapy places have it, where you stand on it and it goes, and there's like bars that you hang on. You hang on to the bars. You're like, and then you step off. You step off and you're like, I feel so good. But you're still vibrating. Like all of your atoms in your body, they're still vibrating and it's still feeling good. It feels pretty good on the spine, the old skeletal. Let's see. So the robot can run an 8-hour shift in a factory or home, realize its battery's low, and completely autonomously walk over to its station, sit down to rest its mechanical bones, and juice up its battery as be juicing. No human intervention required. What's Figure doing over there? Hey, that's Frank. That's Frank the Figure, and that's Gary over there. What they be doing sitting there with their feet on these copper coils. They be getting juiced up. That's what they're doing. They're getting stacked. Those guys be strapped and stacked. Let's see, by moving the charging to the feet via induction, the robot doesn't need open charging ports. Open ports are a nightmare in the real world because they collect dust, lint, and moisture, which can cause short circuits. Anyone ever have one of those really old Nintendo games where you had to, it looked like a brick, well, like you take a brick and you cut it in half, That's what the Nintendo game looks like. And then it had like a huge gaping hole, like a huge square gaping hole in the bottom of it, and would get all dusty, and you have to go get all the dust out so it worked. Yeah, that's a nightmare. Because the charging is wireless, the robot's body can be completely sealed. Making it safer? Yeah, sure. Safer around water, dust, and everyday messes. It gives the old muscles a rest, basically. And that's awesome. You know what, guys? I think on that note, I'm gonna go actually get. I'm gonna get a little bit of water. I say, if a laryngologist is listening, well, they're going to be like, damn, that's my worst nightmare over there. I'm going to get some, I've been drinking these Nixies, and not that they sponsor me, but they can. I love them. You can catch it on Amazon, folks. They say that their cans are BPA free in the lining, because I used to drink Zevia, but their cans, from what I understand, have BPA in it. So you're claiming that you're making this great non-sugar healthy drink, but it's in a BPA line can. Come on. So anyway, this says they don't do that. And, what do I know? It says BPA free can right there. And what do I know? I'm just going to trust them. So this is root beer, bottoms up. Tits up, ladies, tits up. That's what I'm saying. No, I don't do that. Don't do that. No. Just drink it, enjoy it. And you can just keep your lady lumps wherever you want them, but maybe in a nice, a good gate, and in a nice, stack your ribs like that, and have a nice good, what am I trying to say? Have a good gait and a good form, and make sure you are aware of your pitch, yaw, and roll, ladies. That's right. On that note, guys, I'm going to end this podcast. I had such a great time here with you guys today, and I will see you soon. Bye.